This is the Snackable GRE Podcast. Welcome to the Snackable GRE Podcast, Episode 8 by Zemin Review. In this lesson, we will go over the variations of work rate problems for the GRE and GMAT. For this one, we'll need to walk through several examples, and we'll wrap up with our word of the day. Work and rate problems can be a confusing mess. There's also a variety of styles of this question and several common traps. Let's talk about how to navigate this imbroglio of this group of quant questions. Basically, a work or rate problem is a word problem that asks about tasks completed over time. The key formula to remember is work equals rate times time. If you have a hard time remembering this, think of WART. So WRT, work, rate, time, that's the order, where the first letter is to the left of the equal sign and the other two are multiplied to the right. So W is equal to RT, WART, work equals rate times time. This seems simple on the surface, but there are several variations. On the GRE or GMAT, you will often be given multiple workers, either working together or against. They might start at different times or complete a portion of the work and so on. The workers in this case might be people or machines or whatever. When work is combined, working together, the new rate is at which the work is completed, found by adding the rates. So the total rate, the combined rate, is rate 1 plus rate 2. Think of the rates as completing one unit or task, and if you do the algebra on the W is equal to RT formula, then R is equal to W over T, or the rate is 1 divided by time it takes to complete one unit. If you think of work as one whole thing, and you're given the rate in terms of time, you just do 1 over time, and that's the rate for that worker or machine. If this sounds confusing, let's plug in simple numbers. Let's say that Abe works at rate A and Ben works at rate B. Abe can complete one job in 6 hours and Ben does the same job in 3 hours. So rate A is 1 over 6 and rate B is 1 over 3. How long would it take them to complete the same amount of work, that is one job, if they worked together? Well, it should be less than 3 hours to start. Don't do anything silly like add 6 plus 3. It's a common trap. You're not going to have 8, right? If you have one doing it in 6 and one doing it in 3. You don't add the time there. As we discussed, you add the rates and then convert that to hours. So the new combined rate is 1 over 6 plus 1 over 3. For the common denominators, we can do 3 over 6, and that is 1/2. If the combined rate is one job per 2 hours, then it takes them 2 hours to get one job done. That's it. Now, what if the workers don't complete one job, but only a partial job? For simplicity, let's keep the rates of Abe as 1/6 and Ben as 1/3. So if Abe works alone for 2 hours, then Ben joins to help at 2 hours in, how much of the task is left when Ben joins? Well, if he can do the job in 6 hours, the 1/6 rate, then in 2 hours he's done 2 times 1 over 6, which is 1/3 of the job. So if he's completed 1/3, then there's 2/3 left, right? How long does it take him to finish? Well, take them to finish together. The combined rate is 1/2, and W is equal to RT, as we know. So the work now is 2/3. We said there's 2/3 left. So you plug in the 2/3 for work instead of 1. 2/3 equals 1/2 times T. And just do the algebra from there. Remember, the 2/3 is the work. The 1/2 is the rate. We're finding time T. So you have 2/3 divided by 1/2 is equal to time after the algebra, which simplifies to 2 times 2 in the numerator and 3 in the denominator, or 4 over 3 hours. If the question asks for the total time spent, don't forget to add the 2 hours Abe worked by himself to the 4/3 hours Abe and Ben worked together. So you get 3 1/3 hours, or you can write that as 10/3 if you prefer. That's another trap where you forget to add in where one person is working alone before they combine. But wait, there's more. These can get even more complicated. Sometimes the tests like to ask you to solve a problem where one thing is working against another, such as a hose filling in a pool with water while a drain is simultaneously removing the water. Let's try this one. A hose can fill your pool in 4 hours, but the same pool is drained in 6 hours. How long will it take if the pool is drained at the same time it is filled up? To do this, add the rates together. If one is working against the goal, though, remember that it is a negative rate, so they're working against each other. One is filling up, one is taking out. The hose rate for filling in the pool is 1/4, and the drain is -1/6. The common denominator here is 12, so convert these rates to 3/12 for filling in the pool and -2/12 for draining it. Add together, you get 3 minus 2 in the numerator divided by 12, or just 1/12. So that's the rate that the pool is getting filled up, 1/12. So if the rate to fill the pool under these conditions is 1/12, or one full pool in 12 hours, the answer is 12 hours. Now let's look at a more complex and abstract example. This will be our final one. Machine A takes T hours to build a widget. Machine B builds the same widget twice as fast. If machine A and B work together, they finish building in 6 hours. Find T. Your answer choices are A, 3, B, 9, C, 12, D, 15, and E, 18. So right off the bat, we know that when they're working together, they finish building in 6 hours. If T is the time it takes machine A working alone, all we know is that we can write the rate of A as 1/T. Since B works twice as fast, the rate for B is 2/T. Working together, we add. So the combined rate is 1/T plus 2/T, or 3/T. Sounds a little abstract, but that's the rate. It tells us that this rate, 3/T, is equal to 1/6. In other words, they can finish the widget together in 6 hours, so that rate is 1/6. Just do the algebra for T, you get T is equal to 18. So remember, we have 3/T on the left side, 1/6 on the right side. Cross multiply for the algebra, you get T is equal to 18 hours. That's it. That's answer choice E. All right, so let's move on to our word of the day. The word is skullduggery. Skullduggery is a fun word that means underhanded trickery or purposeful verbal misrepresentation. It's intended to trick or deceive you. Synonyms include chicanery and deception. Let's look at an example of skullduggery used in a passage. This quote is from Slate about the Watergate scandal. All of the secrets and skullduggery that were revealed during Watergate created an enormous appetite for explanations and for answers. And the weird bouquet of conspiracy theories that Watergate inspired is a manifestation of that appetite. You can get images in your head about what skullduggery means in this famous example. It's secretive, it's deceptive. There was some hocus pocus trickery and deceit used during this Watergate scandal that caused people to wonder and ask for explanations. There were actions that were intended to deceive you and cover up in a reticent way. That is skullduggery. All right, that does it for today's lesson. Thanks for listening.